Today we're going to be learning bonding basics. So let's just get into it. Ionic bonds between metal atoms and the non-metal atom that transfer electrons in the bond. This happens with different and large electronegativity differences. A covalent bond is when nonmetals share electrons, so like a nonmetal to a nonmetal. Neither atom is able to take an electron completely from the other because the atoms have a similar electronegativity value. Okay? Polar and nonpolar. So polar is the electrons are, well, nonpolar would be the electrons are equally distributed. Sorry. So like carbon chloride. As you can see, the sigma bonds, these negatives are all the way spread out, and they're all even on all four sides. Unlike a HCl atom where you can see the sigma bonds is 1 plus and 1 minus. Alright? What about Lewis structures? Now these are something you may learn in 8th grade, and honors chem and AP chem even. They're very easy and they're meant for covalent molecules, but you can use it for ionic, admittedly. So a single bond just has a line, double bond has 2, triple bond has 3. Now you can use the dots for electrons, but whatever. Example, valence electrons for period 2 elements. Yep, a full valence shell should look like that. It's 8. It means that it's not an ion, and it's ready in its reaction. Alright? Rules for drawing Lewis structures. Number 1, draw the skeletal structure. The central atom is typically the unique atom, or the atom that there is only one of, as indicated by the chemical formula. Today we're going to be doing CO2, so oxygen, carbon, oxygen. Add up the valence electrons for all atoms to find the total number of valence electrons available for the Lewis structure. Remember that the number of valence electrons corresponds to the atom's position in the periodic table. Yep, 6 valence electrons plus 4 valence electrons plus 6 equals 16 valence electrons. So that's good. Form single bonds or draw lines in between the central atom and the outer atoms. Remember, each line counts for 2 electrons. Yep. Okay, looks good. Distribute the remaining electrons to the outer atoms and then to the central atom. Okay. Form double bonds or triple as needed to complete octets. And that's it. And then an expanded version of this Lewis is these. Both of these are correct, and these circles just show where the valence electrons are. So each one of these lines represents 2 different electrons. So you have 4 and 4 for oxygen, 4 and 4, 4 and 4, and then this just shows the same thing. Lewis structures for polyatomic ions, it's basically the same thing, just write it out like this is the sulfate ion and this is the ammonium ion, both with electrons showing and electrons not showing. But then again, this is hydrogen, so it's not really that important. Alright, metallic bonds. Metal atoms are held together by a metallic bond. Atoms in a metal are arranged in a repetition pattern of cations surrounded by a sea of electrons. The sea of electrons represents the loosely held valence electrons of the metal atoms. The valence electrons move freely in the structure, so the structure just like, it's like a cube. It's very similar to a sodium chloride type of structure, of crystal, I should say. The valence electrons move freely in the structure and are the reason why metals are such a good conductor of electricity. Of course, electricity is the movement of electrons through a substance, and if that's already what it does, obviously it's going to be very conductive. Alright, I hope that makes bonding basics a little bit more understandable. Thank you for watching. Have a nice day. Bye-bye.